We do.
All right, so let me share my screen. And let's get started. Okay, I'm Scott Hendrickson. I'm a partner SA at AWS. Welcome to this session on AWS API Architectures. I'm going to be presenting on API Gateway RESTful APIs and Appsync GraphQL APIs. So let's get started.
Scott, sorry to interrupt. Your screen
Yeah,
hasn't started sharing yet.
okay. Let's see what the issue is here. Uh, Not sure. How's it now? Oh, there it is.
Yeah, there we go. Okay, we're good. Okay, sorry about that. Thank you.
Thanks, Patrick. Appreciate that. Okay. Again, I'll start over. Scott Hendrickson, a partner SA at AWS. Currently, I represent a large reseller called SHI and a distributor called Ingram MicroD. And again, we're going to be talking about API Gateway RESTful APIs and AppSync GraphQL APIs. So to a large degree, this presentation and a brief demo at the end will be discussing two serverless API platforms in AWS. Both allow you to create APIs. It'll be detailing the similarities, a little bit about where they differ, and we'll talk some about the managed services that support these APIs. We'll also look at considerations for deciding on when to use each of those. After the presentation, I'll walk through a demo in the console of both of these. So let's start with just a generic API definition. An API simplifies programming by abstracting the underlying implementation and only exposes objects or actions the developer needs. What that really means is, clients don't need to know what backend servers or databases are being used. They could be anything you choose. So APIs act as the front door for applications to access data or the business logic or any functionality really that's on the back end services. So today we're going to focus on AWS API Gateway REST APIs and AWS Appsync GraphQL APIs. But let's first take a quick look at the origins of both of these. I think most people would know REST, right? It's pretty well known. It started around 2000. Roy Fielding influenced REST APIs to a large extent. It's found in many applications today. I'd have to say I've used REST a lot more than I have GraphQL. But that's starting to change. And REST APIs, can deliver payloads in JSON. GraphQL was created by Facebook and then open sourced in 2018. It's really a query language for your API. It's definitely less well known than RESTful APIs, and some of its constructs are a little bit different. So let's dig in and go over both of these. So when you look at how they're similar, both operate over HTTP. Most use HTTPS these days. They're both stateless, which means, the client and the server don't need to maintain state. Both have an architectural style and mechanisms that provide the constraints and guide the interaction between a client and a server. So some differences do exist between the two. At a high level, REST is a software architectural style to which APIs conform so developers can interact with services in a standard way. GraphQL, like I mentioned, it's more of a query language for APIs and also a runtime for fulfilling those queries. And if you get into the details a little bit, both use endpoints for the base domain, right? Maybe something like api.acme.com. REST clients need to specify, though, the resource on the path. So maybe that's, you're looking to get orders from the back end or vendors from the back end. And I say that because the example we're going to use is an ordering system that we have. For GraphQL, it's a little easier because it's always a static path, something slash GraphQL. When you get down into the methods for REST, the client specifies this, and it's something that the server on the back end is listening for, like a get or a post. With GraphQL, it's typically always just a post. And for parameters, REST allows for path parameters or query parameters or delivery in the payload, whereas GraphQL, it's always in the payload you deliver to the API. So the fundamental idea here is that GraphQL API is that all the API functionality is available via this unified query language or the graph query language under a single endpoint. With REST, you're making requests to various endpoints to get different parts of the data needed to build a web page. Let's drill down just a little bit more into some of this. So one of the ways to see the similarities between the two is to look at examples. So again, REST, it's designed for calls to servers, right? So the requests to the servers are combining the resource path with query strings or path parameters and some specific HTTP method, get to retrieve, post to create, patch to update, and the server will return a response. The client then consumes the response, and it might pull out certain bits of the response, but it's always getting that same response back. So in this example, we're going to fetch all the orders that were created for a certain restaurant on a specific date. And you can see that in the HTTP call in the middle there, we're using path parameters to describe the restaurant and the order date. So after setting up an API method, you need to integrate it with an endpoint in the back end. And so a back-end endpoint is also referred to in the API gateway as an integration endpoint. And it could be applications running on EC2 or ECS, Elastic Container Service, maybe it's Beanstalk or code running on a Lambda or any web application. In this case, it's a Lambda function, as you can see, that interacts with DynamoDB. So what you're seeing here is hosted on an AWS serverless platform using API Gateway, Lambda, and DynamoDB, and it returns the JSON payload that looks like what you see below in this slide. So next, we're going to talk about what this looks like in GraphQL. But before we do show a similar example request for GraphQL, let's go over some basic GraphQL concepts because I think that'll be helpful and give you an idea of where it differs slightly from the API gateway. So at the core of GraphQL really is a schema. And so each GraphQL API is defined by a single GraphQL schema. And the schema is used to determine if a query is valid or not. And schemas have object types. So in this case, you can see we have an object type for the order, name, vendor, order, total products. And a GraphQL object type, has a name to it. It has its fields, and ultimately these object type fields resolve to some scalar type, which represents the leaves of a query. So let's just briefly look at a couple object types so you get an idea of this before we show you an example. So, GraphQL has three top-level operations that these object types can be used with. So there's a query, which it reads. It's a read-only fetch. There's a mutation, which is a write followed by a fetch. And they also have subscriptions, right? So those are long-lived connections for receiving data. And it's analogous to REST methods in some respects. And after a schema is defined, the fields on an object type need to return some amount of data. The way this happens is the GraphQL API through a GraphQL resolver. So resolvers have data sources they're attached to. And I'm going to show some of that in the coming slides. In our demo, both the GraphQL APIs and the APIs from the API gateway will both be putting information into DynamoDB. So let's talk a little bit about GraphQL being strongly typed too. So it is a strongly typed protocol. So all the data operations are validated against the schema. So clients simply adhere to one format and responses are based on the query that's passed in. And let's show that here. Okay, so now we're looking at a GraphQL example that's similar to what we showed with the API gateway. To query order info, it's an HTTP post, as we talked about, which is invoked through the /GraphQL static path that we mentioned. And a query, when you talk about a query, will have the query keyword in front of it, and any input parameters, and then the field names that you want to return. So if you're looking to the lower left of the screen here, you'll see we're doing a query, passing in the name of the restaurant and the order date, and we're asking for the total of the order and the vendor to come back. So this is something slightly different, right? Because you can define what is coming back from the API, whereas with REST APIs, you're typically getting everything back unless you're filtering them out in the Lambda. But to point out the similarities here is they're both using HTTP. They're both integrated with some back-end resource, right? And again, in our case, it's DynamoDB. They use an AWS managed service to provide this front door to the back-end services. And now that we've discussed some of the similarities and a few of the differences, let's look at the managed services that actually run both of these. This probably looks familiar to anyone who's worked with the Amazon API Gateway. It's a fully managed service that helps you create APIs and manage them. It's scalable. It's cost effective. You only pay as you make API calls. It allows for multiple consumers, right? So multiple consumers to make these RESTful calls. They could be web. They might be mobile. It could be IoT or apps in a VPC. It's integrated with CloudWatch, which provides you metrics and loggings, and you can use that to analyze or monitor your APIs. It can invoke numerous backend services. Maybe it's Lambda, Kinesis, EC2 instances, DynamoDB. And let's take a quick look at a console view here. So we'll dive a little deeper into the creation of APIs during the demo, but the orders API looks like this in the console. You see the resources and methods on the left. It's implemented with a Lambda function. It could be separate Lambda functions for each resource. These would consume different inputs, maybe path query or resource plus path. When it receives a parameter, it'll parse that input, construct the standard payload, and pass it downstream to the Lambda function. Then Lambda parses this payload, pulls out the details, and makes the query to the backend DB or the post or whatever it's doing. You can see the API URL with the path and its parameters. So let's break this down now for the GraphQL managed service so we can see some of the similarities there. So Appsync is a fully managed service for creating GraphQL APIs. It supports a similar range of clients and can also interact with numerous backend services. It does this through resolvers, which we're going to continue to talk about and get a little deeper explanation of. These backends can be, various things out there too. DynamoDB or Elasticsearch or a Lambda. And with a Lambda, you can do just about anything, right? Or other public HTTP APIs. It also is integrated with CloudWatch, which provides metrics and logging so you can analyze it. The point here is these two AWS managed services are providing some similar capabilities for supporting the runtime aspects of APIs. Let's just briefly talk about Appsync resolvers. Again, data sources and resolvers are how Appsync translates your GraphQL request and fetches information from AWS resources. So resolvers are responsible for retrieving the fields from a data source and then mapping them to your schema, right? Resolvers in AWS Appsync use mapping templates written in Apache Velocity template language. Resolvers can be automatically provisioned by Appsync in some cases. And the resolvers in the fields have a one-to-one relationship with a large degree of flexibility. And in fact, in this example, you're seeing the object type be returned by two resolvers. Most of this could be returned directly from DynamoDB, like the name and the order, the total, the vendor, and the products. But the order discount might be coming from a different data store or require a different amount of processing. And so multiple resolvers can be called in order to fill that object type. And this is just showing, in this case, we're asking for all the orders for a restaurant on a certain date. As a client, I'm invoking the query get orders and asking for the total and the vendor, and then Appsync will map that data to DynamoDB resolver and query the items to match those input parameters. All right, so I've talked about the similarities and some of the differences, right? They're both have managed services that allow you to create and maintain APIs. They're integrated with CloudWatch for metrics. They both have similar security aspects, and we'll talk a little bit about those when we demo. GraphQL is slightly different, being a query language and a proxy to execute those queries in. So how do you decide? And really deciding on the right API really depends on your needs and perspective. From a developer's viewpoint, generally, the general support for REST is more widely accepted. We see a lot more people currently using REST than we did with GraphQL. But GraphQL is gaining a lot of popularity. One of the things I would say is that not all data sources are supported out of the box by GraphQL. So if your data stores run outside of AWS, or you're using a type of database that isn't supported by Appsync by default, you may need to spend some extra time implementing a data connection layer in your AWS Lambda functions, just so you can use these other data stores. And when it comes to clients, I think all modern browsers support APIs via JavaScript. For GraphQL, you do need an SDK or some additional tooling in some cases. The Amplify framework is something that can be used with GraphQL if you're completely inside of AWS. When it comes to tools, you can use Postman for GraphQL. With REST, you can use Postman, curl, wget. And our examples will show Postman making calls. When it comes to ease of use, I think some people would say GraphQL exchanges data at a single endpoint, whereas REST often involves several endpoints. Others might say that GraphQL can simplify requesting different entities from your API at the same time, kind of that example we showed before. So you may be able to build a complex web application that, brings back multiple amounts of data. We've heard that is a reason for using GraphQL. Another one is what we're going to show in the demo too. So typically the REST data size is defined by the server, and the response has a known, a size. So when we're calling get order, we're bringing back all of the products, the name, the vendor, the total. And in a lot of cases, that could be a lot larger JSON payload than just that. I'm using that just as an example. But with GraphQL, the data size can change based on the data requested. So you see a lot of mobile app dev using GraphQL. I think one of the reasons you see a lot more REST right now is adoption challenges. So there's some complexity to GraphQL, and it's a kind of a new way of thinking around building the schema and then the resolvers to execute on your schema. So the skill sets inside of enterprises are probably more aligned with REST, or you have more engineers that have used REST. Sometimes we hear maybe it's easier for net new applications to use GraphQL versus those that are being migrated. So typically, if you're migrating something from on-prem into AWS, it's usually REST that you're moving from, one area to another. So one area where GraphQL seems to have a small advantage over the API gateway is around the WebSocket implementations. So both API gateway and Appsync GraphQL have a WebSocket implementation. Appsync subscriptions, as they're called, are implemented using WebSockets, and they're directly tied to a mutation in the schema. And all of that mapping is taken care of for you underneath by the management of Appsync. Whereas with WebSockets that are part of the API gateway, you maintain that mapping. So those are some of the primary considerations when you're looking at whether you're going to use the API gateway to build APIs or whether you're going to use Appsync GraphQL to build your APIs. Okay, so at this point, I am going to go into a demo, but I'll stop here if there's any questions that anyone has, or there's anything, see if there's anything in chat window. Yes, loud and clear. Okay, doesn't look like there are any. So let's go into a demo. All right, so we are in in AWS console, looking at the API gateway. For this presentation, I've created just a small API. And again, the API gateway is a managed service to publish, maintain, monitor, secure your APIs. And when you create an API, it's a collection of programmable entities known as API gateway resources, like in this case, an order that I'm showing, right? And orders will have different methods to them. Maybe it's a post, maybe it's a get. And those methods, like a post, will have integrations. And so in this case, our post is, we look at the integration here. It's a Lambda function. So we have a Lambda function called create orders. And this Lambda function will, let me move this out of here. This Lambda function, we'll just briefly look at it, is going to interact with DynamoDB and add data to it. And if we come back to the method execution, what we can see here is that there's different ways to secure this API. And in the case of this demo, I'm just doing it with an API key. But I could have created a Cognito authorizer and attached that authorizer to it, or used IAM. So security is built into this. And the other thing I'll point out is, with RESTful APIs inside of the API gateway, you have a mechanism to test, your APIs before you deploy them against your Lambda function to make sure it's hitting DynamoDB and bringing things back. With RESTful APIs, like we talked about, it's integrated with CloudWatch, so you're able to see metrics about your calls and do some analysis on it. So this is, what I'm showing here is kind of the typical serverless architecture with API gateway, Lambda, DynamoDB. In a lot of cases, like I mentioned, you would have Cognito governing, the auth portion of that. And what I'm going to do now is just show you examples of calls in Postman on this. So let's first look at actually creating an order. So what you're going to see here again is the resource order in the post. With my header information here, I'm adding an API gateway, right? In the body, I will have the information that I'm looking to add. I'm just going to change the date on this one slightly. And we'll send a request. And so I have posted something successfully, through Postman to the API gateway, who's called Lambda, and inserted that into DynamoDB. A GET is very similar here. You can see we're asking for, the orders using the restaurant Nona Blue and a certain date, and that's going to bring back certain information. And again, like I talked about, you're always going to get this same JSON payload unless you're filtering it out in, in the Lambda. And we're going to show a little bit of how that's different when we get to GraphQL. So let's do that. Let's bring this down. Let's go over to the Appsync console. And I've got a couple different APIs here. So let's look at the Appsync Orders API. So again, Appsync is also a managed service to publish, monitor, and secure your APIs. Under the hood, like I talked about, Appsync consists of this GraphQL proxy. It's a service that, receives and parses your GraphQL request. As we talked about, the supported, request types are queries for getting data from the API, mutations for changing the data, and they also have subscriptions. And the Appsync interface, allows developers to define a schema that, you'll attach to these resolver functions. So if we look at the schema that's here, you can see, one of the core pieces is this type. So we have an Appsync order. It looks exactly like what we posted for the API gateway. So you're just describing it in the schema. Your schema will also define how you're going to deal with certain data. You have mutations, so I can create an order or a query where I get the order, or subscriptions that says, hey, anytime a new order is updated, let me know about that. And if we look at what a mutation looks like, right? So we have our schema. We know that the GraphQL proxy, when we send it a request, will validate what's in that schema against what's in the request and reject anything that's not. And then you have this concept of resolvers. And resolvers are always going to map to a data source. So in our case, we have one data source. It's DynamoDB that we're using. And if we go back and look at what a resolver would do, anyone who's put stuff into DynamoDB, maybe using Python or other languages, can kind of see here that the resolver is calling a put item request, and it's giving it the keys of DynamoDB that are in there. In this case, the name and the order date are the two keys for DynamoDB. So these resolvers, this is a very simple resolver, but resolvers can also be pipeline resolvers where it's one after the other doing certain things. Maybe one of the things you want to do is validate that the person trying to execute this resolver has the right permissions. It is one of the use case for using them. Just like the API gateway, I can execute some tests on each of my queries or mutations or subscriptions that are in there. and you can also, from a security standpoint, I only have API keys set up, but I could be using Cognito here as well. So very similar. And then, of course, you're going to get some level of monitoring that's very similar to, the API gateway as well. So again, kind of looking at these, while GraphQL is a different construct for creating these, you get a lot of the same type of functionality between the two managed services inside of AWS. So let's go ahead and execute a couple of these using Postman so you can see some of the differences, and then we'll just do a recap. So here are my GraphQL APIs. So again, what you're seeing here is you're seeing some of the headers that are getting passed over to a create order API. And we do have to specify a content type of application GraphQL. We're giving it an API key. Postman supports the body for GraphQL now, so you're able to see the query that I have here, right? So, or the parts of the create order that I have here, and these are the variables that I have here. So we're creating a new order to the restaurant called Pussers. Happens to be in Jack's Beach where I live, and it looks like they're ordering some double IPA. And again, so we sent that. And I think here's where I want to show you a little bit of the difference. From the get order standpoint, right now, I'm going to get orders back for a certain restaurant and a certain date. And when I do that, what comes back in the request is not everything in that payload that is part of the order's type. It's only what I asked for. So I might ask for vendor here as well. And then I'm getting back the vendor. So that is one of the differences between kind of the API gateway and the backend integrations there and GraphQL. It only returns the attributes that clients ask for. So to recap here, these two services inside of AWS have a lot of similarities. Both provide a way to create, publish, test, and run your APIs. Both allow for authentication in similar ways. Maybe it's API keys, Cognito, IAM, even Lambda authorizers. Both have monitoring and logging capabilities integrated with CloudWatch. Both provide an underlying WebSocket interface. I would say some of the differences here are that GraphQL has a single endpoint, typically a post. It's the API gateway WebSockets, are a little different than the WebSockets inside of Appsync. And, you can think of Appsync more as a query language for your requests that are out there. All right, so that's we still have a few minutes left, but that's the basic presentation with a quick demo on that. Any questions that I can answer? Okay, so we have one here. I'll just stop sharing. in my opinion, what is the biggest advantage GraphQL has over REST APIs? So for me, I think there's a couple of things where I like GraphQL. One is for mobile apps when it's integrated with Amplify. With mobile apps, you typically only want to bring us back a small amount of data sometimes, or sometimes only make a single call which pulls back data from different resources, right? So maybe you want to pull back all the orders, all the vendors, and order guides as something. You can do that in a single call, whereas typically in REST, you're making multiple calls. Also, with Amplify, you're able to actually get some offline data stored when you don't have connections to the cloud. That's helpful. And what you see is a lot of people using GraphQL when they're doing mobile gaming, when they're doing chat applications, or when they're doing any kind of mobile, maybe using React Native. And I think part of that for chat applications is the subscription capability or the WebSockets capability inside of GraphQL has some advantages over RESTful APIs, the WebSocket interface there. With that said, the one thing I would also point out is there's a lot more RESTful APIs still than there are GraphQL. Yes. So on the other one too, on pipeline resolvers, they are executed synchronously, and yes, you can pass the output of one to the other. There's mechanisms to deal with failure inside of these resolver APIs as well. Sometimes there's issues when one does fail, but you can log that and be able to deal with it appropriately. I think, again, for pipeline resolvers, there are often use cases where you want to do 2 or 3 things without touching a backend database before you actually insert or fetch from something like DynamoDB. All right, and I talked about that a little bit. One of them might be, authentication. You typically see sometimes incognito, there's groups. And if you're not part of like the admin group, but still have access, to the GraphQL APIs, you could be filtered out in the pipeline resolver. Sometimes it's really just used also to log certain information first, before you call like an authenticator. So let me ask you guys a question, I guess, is anyone out there currently using either the API gateway for RESTful APIs or Appsync for GraphQL APIs? Any answers there? Okay. And are you using RESTful APIs inside of? Okay. API gateway for multiple apps. Yes, REST. Okay. Yeah. Yeah, this isn't surprising. This is typically what we see. A lot of enterprises will use RESTful. We use API gateway for REST APIs, but different technology for GraphQL. Yeah, again, one of the things where we've also seen GraphQL and Amplify sometimes are used, outside of even gaming or mobile apps, and they're starting to catch on a little bit too, because you'll see like video on demand applications where you might be hosting that using Amplify. And because Amplify is well integrated kind of with Appsync and GraphQL, you could use the Amplify storage mechanism in order to upload to S3. So you do see GraphQL kind of, being used in different use cases besides the ones that I talked about, REST APIs and EC2 and Lambda. Yeah, I mean, REST is the predominant API that we typically see. What does auth N and auth Z look like? For example, could you restrict a client from executing certain mutations, introspection? So again, the example that I give is for this one is like incognito. And let's just talk about it in the context of this video on demand application. So you've got a video on demand application. Your admins are the only ones who can upload video, and everyone else really can, view the videos that get uploaded. But all users are inside of Cognito. And so you could have a group inside of Cognito, call it admins, and everyone who's authenticating to use a GraphQL API, whether it's to pull from S3 to get the video or to upload, could be checked through a pipeline resolver to determine what group they were in, in order to restrict the access to certain actions or a GraphQL call. So you get some level of fine-grained access into, a GraphQL API. But I will, there's other things too. Is excuse me, just to be clear, GraphQL is still relatively new, although it's being used a lot more. So there are some GraphQL limits, right? I'm trying to remember all of them, but there's like, you have a limit of 25 Appsync GraphQL APIs, and I think 1,000 or 1,500 queries per second. There's a maximum number of API keys per GraphQL API. I think that's fixed at like 50. These can be upped. I think the schema itself that can only be like 500K or a meg. I think it's a meg. So, there are still some limitations that restrict GraphQL APIs as you look into them more. So some of them are part of Appsync, and some of them are part of the GraphQL API as well. All right. Let's see. Patrick, did I provide you my information? Let me do it here in the chat.
Yeah, that'd be great. I didn't catch your official email.
I'd like to hear about your experiences with GraphQL or any questions that you have. I'd be curious about how this fits into GIS solutions, so kind of mapping solutions maybe. I'm not sure. That I could see what kind of use cases we've seen with that. What would be the use case you're looking for? Just plotting various lat longs or points, or something else? But please send me an email if you have any questions, either about the presentation or you start using API Gateway or GraphQL, and have some questions there. And I'll also say I'm looking forward to some of these other meetups that you just described too.
Yeah, absolutely. We had a little bit of a lull, I think, coming out of reInvent and then coming out of the holidays, but we're definitely forming a nice backlog of presentations. Especially from folks such as yourself, Scott. So
Yeah.
we really appreciate your time tonight, and everyone else for coming out. It looks like maybe a few more questions came in. I don't know if you want to take a
That's it.
moment to answer those, Scott.
Would you ever pick one over the other if you were looking at a security footprint? I'd probably, if security was kind of your main focus, I still would go with RESTful APIs. I think they're better suited for that in some respects. They're I just think in general, if you have an enterprise application, um, and it demands kind of security and performance, I like RESTful APIs for that. Mobile applications where everything's developed inside of AWS and you're using Amplify and GraphQL, I kind of like GraphQL there. Chat applications, I think the subscription capability is better for GraphQL. But there's people who will argue different sides of that. And what I tried to do tonight, to a large degree, and was show the similarities between the two. Because sometimes people don't entertain GraphQL because all they know is REST. But there's a lot of similarities both in the managed platform as well as the APIs in terms of being able to test them, monitor them, and secure them. Not all the same security features are there, but they are very similar. And I can kind of tell just from the questions that came here, most people in this group are still using RESTful APIs. And frankly, my partners are too, as they're doing different work for their customers. And so I would ask that to you too, Patrick. I know you're at Cloudhesive, right? What do you see as you're consulting with customers? Is anyone asking for GraphQL? Are you implementing GraphQL for any of your customers?
That's a great question. I think, what we're seeing mostly still follows kind of the API gateway patterns,
Yeah.
a mix of REST and non-REST. Where, where I'm predominantly seeing, or where we're predominantly seeing the use of GraphQL is applications that are built on Amplify. Just because
Yeah.
it's pretty inherent to the application. So no explicit like decision trees that maybe point one way or the other. And I mean that was the thing that was kind of great about about your topic and presentation is it kind of got me thinking and looking at there's maybe some great use cases here that we've just simply overlooked.
Yeah. And I think you'll probably hear more about it as time goes on too. All right.
Yeah, it's one of those things where I think I could be wrong on timing, but I feel like Appsync and Amplify kind of came out along similar timelines, and sometimes that tends to be a little bit confusing.
Yeah, that's true. And I think you're seeing the service itself evolve. If you can remember what the API gateway interface looked like 2 years ago or so, or even 3 years ago, the AppSync GraphQL interface it's got some room to get better. Let's put it that way. So, and I think that'll happen as time goes on.
Absolutely.
All right. Thanks, everyone.
Well,
I
thank you
appreciate
again
you
very much,
having us.
Scott.
Have a good night.
Good night, everyone. Thank you.
Thanks.